So this video, I'm going to talk about what are called power functions, what they look like, how you can generalize their power functions into different polynomials. And so what we're going to talk about first is just what is a power function. A power function is a polynomial written in, and I'm going to zoom in, this format right here, okay? So p of x is the power function, and you've got a times x to the n, where n is a non-negative integer. Now, really quickly, just so you know what non-negative integers would be. That would be 1, 2, 3, 4, and it's going to keep on going. All right. So those are your natural numbers, your counting numbers. And basically, you could have things like x to the 57th. You could have x to the 312th. Those are considered power functions. Now you'll notice there are no other terms after these. So this isn't going to be x squared plus 7x. It's just x squared. All right. So let's take a look at their graphs and see if we can kind of generalize some information about these. So your first power function is y equals x. So if we look at y equals x, we know that this is linear, all right? And we know that this is degree 1 because that x would have a power of 1. So now it's a straight line. You guys have graphed lines for a long time, all right? So you kind of know what a power function looks like when we're talking about a line. Now, we have spent a lot of time on the next one. So y equals x squared. This is your quadratic. So this is a quadratic function. It is degree 2 because it says x squared, all right? And so we worked with these. We've seen where they can be concave up, concave down. We'll talk about a little bit of that later on, but this is your general quadratic shape, all right? Now you've seen a little bit about your cubic functions, okay? Your cubic function here is degree 3, okay? So it's a third degree function. And it kind of, I always think of this as kind of like a weird little S shape because depending on if this wasn't a power function, you could have a stronger, S curve in there that you might be able to see. All right, so let's move on to the next one. Okay, this is y equals x to the 4th. I know it's kind of hard to read that little 4 there. This is a Quadratic function, all right, and this is degree 4. And it's kind of interesting because if I look at this Quadratic function, it kind of makes a U-shaped graph similar to my quadratic. Now, is it identical? No, of course not. It's a little, I almost want to say flatter around the origin, and then these edges are much steeper. All right, but kind of the same U shape-ish kind of helps me out there. Okay, next one is a quintic. So that's x to the 5th. This is degree 5. Okay, and it's kind of interesting because this one, if I wasn't looking closely at it, I might think that this is the same as my third degree function. Kind of makes that same S shape, all right? Same thing happens here. It's a little flatter around the origin, and then these edges, as you are going towards infinity up and infinity, negative infinity down, they're much steeper, all right? It kind of looks similar, but there is a much steeper curve there. So then we've got another one here. This is x to the 6th. There's no special name that I know of for an x to the 6th. What I will say is this is degree 6. And if I look at kind of all of these, now the linear function stands on its own, all right? It's just a line, we're used to that. But if I look at these degree 2, degree 4, and degree 6 here, they kind of all look the same, all right? They're kind of that U-shaped curve. And if you notice, 2, 4, and 6 are all even numbers. So these are all even degree functions. And your quintic and your cubic, degree 3 and degree 5, those are odd degree functions, kind of make that S shape, okay? So that's going to be really important for us to get to know what those curves kind of look like in the power functions, okay? So the next thing we're going to be doing is we're going to label the next 3 power functions. So we left off here with degree 6. So this next one's going to be degree 7, which means the power function would be x to the 7th. And I'm just going to write degree 7 off to the side to remind us, okay? Now, 7 is an odd number, which means that this sketch should look like the odd degree functions. So go ahead and do a quick sketch that's kind of that S curve. It does need to go through the origin, okay? And yeah, it probably should be a little flatter around the origin, but it gets the idea of what the function looks like. And that's the important part that we're looking for here, all right? The next power function would be x to the 8th. This is degree 8. That is an even degree function. And so that means it should look like the quartic, which would be my degree 4 or my degree 6. So kind of that U-shaped graph. Again, it does go through the origin, okay? That's not curved that well for me, so let me try that again. Let's curve that a little bit better. Yeah, a little bit better this time. All right, so it's that U-shaped graph. It does go through the origin, and make sure that it's concave up for the power function that we've got right now. All right, last but not least, for the little sketch here, we're going to do x to the 9th. So this is degree 9. And that means it is an odd degree function, which means it should look like my degree 5, degree 7 functions, kind of that S-shaped curve. As your degrees go up, it's going to seem steeper and a little flatter around the origin there. But basically, if you were to graph these all together, it would be getting steeper and steeper and steeper as you go up in the degrees. Same thing with the even degree functions. Okay, so I'm going to go ahead and close the video for this page. I will make other videos for the other pages in this note sheet. But if you have any questions or concerns just on these power functions, please send me a message in Canvas or send me